Right. And what were those questions? So those questions I have also asked in the exam. So let me just, I will just draw the diagram and that would be, right. So that would be enough to understand the question. So what was the question? Yeah. So the first question was like this. Right, these are pulley system. So Maria asked about some more questions on this thing. So two questions from this one. So this is the rigid wall, right? And then you have this string. So this pulley is attached, and then this string is going upwards, and then you have another pulley, and this is attached in here, and then this is going downwards. And in here you have a force. So the force value is given, that is 2 mg. And this is right. So, and then you have this mass, which is hanging. Right. So this was the question, and you have to find out the acceleration on this block. So you have to find out the acceleration on this block. Right. And yeah, and we have to remember that these strings are massless. So strings are massless, which means that the tensions would be the same, right? Tensions would remain the same if strings are massless. Okay, so what do we have? So in this part, there are no mass, right? So how many forces are acting on this thing? How many forces are acting at this point? Remember, this has no mass. So how many forces are acting? We will so break it in two parts. This is 1, this is 2. Right. So how many forces are acting on this thing? Can you guys tell me in this one? How many forces are acting? And remember, this system is in equilibrium. So system is at equilibrium. Yes, guys. Oh, how many forces are acting on this one? So one force is downwards, and then you have tension upwards, right? In this one, you have also the tension upwards. In this one, you have also tension upwards. So there are two tensions, so you have 2T upwards, right? So at this part, let's say this is 1, at 1, right? At 1, we have only two forces, and there we have to apply the equilibrium condition. So two forces, one is up, the other one is down. F is equal to simply T, right? Because they have given the value of MA, right? MA is given, that is 2 mg. So this thing is how much? How much is this thing? 2 mg, and that is T. So tension is 2 mg. Is it clear, guys? Is it clear? Yes, guys, is it clear? How many people are here? So there are 9. Oh, everybody joined today. Yes, Madia, hello. Assalamu alaikum. And who's the other one? Okay, Chavez is still not here. Yes, so this is on this part. And then on this one, right? Because this thing is pulling it downwards. This string is going upwards. This is going upwards. So this thing is pulling upwards. So we have acceleration upwards, right? Gravity downwards, tension upwards. So if we write on the second part, right? If we write the second part, so what we will have? What we will have? That is not at equilibrium, right? This thing is moving. So what would be this thing? Yes, guys, what would be this thing? Yeah, so MA at second, right? Second law. MA is what is in the direction 2t minus of mg, right? So MA 2t is 2 into 2 mg minus mg. So MA is 4 mg minus of mg. So M cancels and A is 3g. So this is, okay, somebody has written in the chat box, A equals to 3g. Yes. So this would be the answer. Is it clear? So we have to apply the free body diagram in two parts, in this one and in this one. So in this one, we'll apply the equilibrium condition. And in this one, because this is moving, right? So we will apply the, right? We will apply the acceleration condition. So is it clear with everyone? If
Yes.
it is clear, yeah, please note it down. And then we'll do the second question, and then we'll get back to the work energy and power. So quickly note this one down. Yes, Maria, your answer is correct. So A is 3G. Yes. Whenever you guys have noted it down, please tell me. Yes, noted, guys. Everyone noted. Noted. Okay, so now let us do another question, which was right, which was again the pulley system. So what was that? So the question was, yeah. So you have a rigid wall in here, right? And then you have this angle, and then you have some weight, right? Downwards, W1, and then you have this thing, and then you have a pulley, and then you have this thing, right? And again, the rigid wall, and then this is downwards. This is W2. And they have also given the value of these angles. So this was 37 degree, and this is 53 degree. And the important thing in this one is that this thing is at equilibrium. So this thing is at equilibrium. Right. And you have to find out what is the question was, find out what is W2 by W1. Right. What was W1 by W2 or W2 by W1? What was that? Yeah, let me check that. So W1 by W2 we have to find out. Right. So W1 by W2 we have to find out. Again, right. we have three parts or we have two parts. So one is this part. So on this block, we have to apply the free body diagram. And remember, it is at equilibrium. So every force, they are balancing. So, and this one, right? These are not moving. These are stationary. So there's no acceleration in here. Whenever we have acceleration, so then we don't have equilibrium. But these things are at equilibrium. So no acceleration, right? So this weight is attached in here. So this will have same tension, right? And then the other weight is here. So this tension would be different because this rigid wall is different, right? So then we have, let's say, some tension T1 in here, right? Tension T1 in here. Then we have tension T2 in here. And then we have, right. So then we have tension T2 in here. So this is the free body diagram, right? And what do we have? So we have, let's say, this X and Y axis, right? For here, this is the X and Y axis. So this part is easy, right? This part is easy. So if we can directly apply the equilibrium condition, so T2 would be simply because this is weight, right? W2. So W2 is simply equal to T2, right? Because let's say this is second. So in second, everything is at equilibrium. And in one, right? In one, we have two components. In one, we have horizontal one. And then we have vertical one. So let's solve this horizontal one first. Right? What is the horizontal one? So this thing would be how much? T2 sine 37. Right? And this is with the angle. So this is T2 cos 37. Right? And then what do we have? So, and then we have T1. Right? And then we have T1 cos 53. And this is T1 sine 53. Right. So in horizontal one, these parts are balancing. For horizontal part, we have T1 sine 53. And this is equal to T2 sine 37. So can anybody tell me what is sine 37 and cos 53? We have to remember that what was cos 37? What was cos 37? What was cos 50? What was cos 53? Do you guys remember? This thing we have discussed, right? That is why these things we have to memorize. What was cos 37? Do you guys remember? Yes, so this was 4 by 5, right? And it was equal to, yeah, so cos 37 4 by 5. Yes, absolutely correct. And this cos 45 is equal to sine of 53, right? And then we have sine 53, that is 3 by 5. And this is equal to sine 57. Right? So these values, if we put these things, so we will have T1 and 53 is how much? Sine of 53, 4 by 5. And then T2 sine of 37, 3 by 5. So 5 cancels and we have T1 by T2, or let's write 4T1 as 3T2. So this is from the horizontal equilibrium, right? If we write the vertical part, vertical equilibrium, Then what do we have? So the downward part is W1. So W1 is equal to how much? T1 cos 57 plus T2 cos 37. Right, how much is this thing? So W1 is T1 cos 53 is how much? 3 by 5. Cos 53 is 3 by 5. And T2, so plus T2 and 4 by 5. So 5 is common and we take it in the right hand side. So this is W1, then this is 3T1 plus 4T2, right? Okay. So we have, and we have to remember that T2 is W2. So we have to write everything in the form of T2. So how much is T1? T1 is 3 by 4 T2. Right, so if we put this thing in here, so 3 and 3 T2 by 4, and this is 4 T2. So how much this thing would be? 5 W1. So 5 W1 is 9 T2 plus 16 T2, and then this is 4. So what do we have? We have 5 W1, and this is, so who's writing some answer? 5 by 4. So Maria is saying 5 by 4. Okay, let's check that. This thing by 4. So I will take the T2 in this side and 5 in the other side. So 25 by 4 into 5. So yes, 5 by 4, I know that T2 is simply, T2 is W2. So if I put that value, so W1 by W2 is 5 by 4. That is the answer. Right, so this is some question based on pulley. Is it clear, everyone? Is it clear, guys?
Yes, sir.
Yeah, please note this thing down. Please note it down, and whenever you guys have noted, please tell me. So then we'll go to the work energy power, right? Whatever questions we were doing. So in the next class, I will start maybe AC. AC I will start, right? Yeah, whenever you guys have noted, please tell me. And let me have some water. So who got disconnected? Who's getting disconnected again and again? Yeah, one moment. I will just bring some water. Yeah, whenever you guys have noted it down, please tell me. Yeah, whenever you guys have noted it down, please tell. Done. Okay, so now let us move on to the next question. What were so we were doing? I guess the work part we completed, right? So the work part we completed, energy we completed. So this question was based on equilibrium, right? At equilibrium, the net force was zero, and then we used the idea of potential energy, right? So when this thing is applicable, tell me, when only we can apply this thing? F is minus du by dr. When this is applicable. Yes, do you guys remember this thing? When this is applicable? F is minus du by dx. Gradient of potential energy. When this is applicable. So this is only applicable for what kind of forces? So this idea is applicable for conservative forces, right? So when there is no force, right? And for that, the total energy is conserved, right? So this thing we have to remember, and these questions we did, right? Okay, so and there's something remaining in here. Do we have anything which is remaining? Yeah, this thing I told you guys to solve, right? Humanity becomes 4 times of its then percentage. So these things we have done, right? Same amount of work to a certain in the direction respectively one by one. So these things we have done. Okay, so now let us understand what is power, work, energy theorem, and all those things, right? So we already know the concept. What is work energy theorem? I will specifically talk about vertical circle because that diagram is important. I will derive that part, right? I will specifically derive that part. But before that, yeah, so let me just, this thing is very important, right? This is applicable for any kind of forces. Dissipative force, conservative force, any kind of force. So total work done, that would be change in kinetic energy. And this work done can be friction, this work done can be dissipative, this work done can be any kind of force, right? So this is not necessarily that the work done should be of conservative force, right? So if work done is done by the conservative force, then change in kinetic energy, that would be equal to potential energy. So kinetic energy plus potential energy, that would be conserved, right? Whenever we have conservative forces. So yeah, that part is there. So this relation is very, very, very important, and we will use this relation. And we will also use, okay, so what is happening? Why this is blank? Yeah, so we will also use the vertical circle. Right. So we will also use the vertical circle. So let us understand the vertical circle first. And then we'll do one question and then we'll get back to the work energy theorem. So what is a vertical circle? Right. Let's say you take, okay, let me, yeah. So what is a vertical circle? What should I take? Yeah. So we have, let's say this mass, right? I have this mass and I rotate it in this way, right? So I'm not rotating it in this. This is horizontal circle. I'm rotating it in this way, something like this one. Right, so I'm rotating it like this. So this is rotating like this one. So this is vertical circle, right? So I will have what would be the diagram? Right, let me just draw the diagram. And this question is very important, right? So this you have already studied, but I want to draw your attention to the diagram. So, okay. And vertical circle is related with the circular motion. In circular motion, you don't have any. So we are neglecting the air friction. So which means that we are talking about the conservative force only. So the force which is there is only the gravitational force. So then the potential energy plus kinetic energy, total energy would be conserved. Right. So that is the idea. Okay, so but before we start, so we have this, right? Let's say we have this thing. And this radius is r. So this would be obviously 2r, right? This is also r. And I have 3 points. This is A, right? This is B, right, at the 90-degree, right, at quadrant. And then this is C. So these are the 3 points that I have. And let's say I pick my base or reference as this one. So this is my reference, right? And yeah, so then if I talk about these 2 points, I have 2 concepts, right? I have 2 concepts. One is the Newton's laws of motion. So this is one concept. Second concept is energy conservation. So what do I mean by that? Energy conservation is that potential energy plus kinetic energy that is conserved, right? So that is a constant, that is E. That is the total energy. So I will use these 2 principles to find the relation between what is the goal. The goal is to find out the velocities at different points. This is the goal. Okay. So these are the 3 things I have to find out. And what do I have? Right. So I know that I know these 2 relations. Right. So let's talk about A point. First is at A. At A, first talk about this laws of motion. So what do I have? I have, let's say, this is the rope. So tension is towards here. Let's say this is T1, right? And I have this. This is some mass, so mg downwards, right? And then this is moving with tangentially. This is moving with VA velocity, right? This is moving in circles. So what would be the other force? Can you guys tell me? What would be the other force? Can you guys tell me? Yes. What would be the other force? So somebody has written in the chat box. Centripetal force. Yes, Maria. Absolutely correct. So we have the centripetal force, right? That is towards the center. So how much would be the centripetal force? right? So how much would be that? FC, that would be equal to T1 minus mg, right? So how much is this thing? This is half mva square, and this is T1 minus mg, right? So this is the thing. And what else do I have? Right, so let me write the total energy at this point. Right, so what is the total energy? Total energy, that is E, and this would be how much? So I have chosen this reference, right? So height is 0. So potential energy is 0. Right, let's PA and kinetic energy at E. So this total energy, this is 0 plus half, right? And kinetic energy is mva square, right? So I have total energy, which is half mva square, right, guys? Clear? So this is at A. Now if I write the second part at B, right? At B, the first thing is laws of motion. Right, so what does this laws of motion says? I have this is in here, so I have tension in here, let's say T2, right? And because this part is mg, right? This is mg and this is moving in this direction, so this is vb, right? This is again moving in circle, so I will have the centripetal force, right? And I don't have any this part, horizontal force, only this tension and this FC. So my centripetal force, that would be how much? That is simply T2. So how much is this thing? Half mvb square, and this is T2. Right. And also, what do I have? So I also have total energy, that is how much? E. So E is potential energy at B plus kinetic energy at B, right? So what is the potential energy? mgh. And what is the height? How much is this height? That is R. So potential energy is simply mgr, and kinetic energy is half mvb square. So I have got this relation. E is mgr plus half mvb square. Right. So this is the thing. And then if I reach this point, right, if I reach this point, so what is the idea? So at C, what do I have? I have laws of motion. So again, what do I have? I have again centripetal force, right, towards its direction. And then I have this mg in the same direction, right? So I have mg, And I have this centripetal force, right? So, and I have this tension as well. Let's say T3. So how much is this thing? This thing is, okay, let's see. So centripetal force is mg plus T3, right? So Fc is mg plus T3. So this is mv, and did I write mv square by r? Oh, why did I write half mv square, right? So this is not, this is mv square by r, right? This is kinetic energy. So mv square by r, and then this is also mv square by r. Why didn't you guys correct me in here? And then I have this thing mvc square divided by r, and then mg plus T3. Right, so this is, these are the conditions that I have. And if I use the total energy, so how much would be the total energy? This thing is simply, so total energy in here at this point, potential energy at C plus the kinetic energy at C. So potential energy at C plus kinetic energy at C. So this is mg and 2r plus half, right, mvc square. So this is the total energy. Right. And yeah, so these are the six equations that I have. Right, these are the six equations that I have. So this is first equation, right? And then I have, this is my second equation. And then I have this third equation. And then I have this fourth equation, right? And then I have this fifth equation. And then I have this sixth equation. So I have these six equations. And solving these equations, I can get the different results, right? So let's solve this, firstly, solve this fifth one. So we can, at this point, right, at this point, we can assume that the tension is less, right? Tension is minimum, so we can neglect this part. We can neglect this part, and what we will get? So we can neglect this part, and we will get, so using equation fifth, right, and neglecting, but in some question we have to use this tension, right? So we'll use that, and let's see, yeah, what we'll get. So neglecting T3, what would be this thing? MVC square by R, that is mg. So what do we have? VC square by R is mg, R by m. So VC square is simply root gr. So this is VC. So the speed at this point would simply be root gr. Right, so this is the idea of vertical circle. And then how can we solve this VA, right? So to solve this VA, we will use this idea. Equation 6, right? Using equation 6. So this is a lengthy calculation, right? But we have to, I will just tell you guys that what we need to remember, right? But the idea or applying the free body diagram and all these things, That is very crucial. So that thing is important. That's why I did this, right? So yeah, we have to solve this equation 6. And what we can do in this equation 6 so that this can be useful. What we need to do in this equation 6? What are the unknowns and what are the known? What are the unknowns and what are the known things in this equation? Can you guys tell me? In equation 6, what are the unknowns and what are the known things? Yes, guys. VC in 6. Good. Absolutely right. Yeah, that is what we need to do. So we have to substitute this VC in here. Right. So this is the unknown. Total energy is the unknown. And that is always fixed. Due to energy conservation, total energy will always be fixed, right? So in here, maximum, in here the kinetic energy is maximum. In here the kinetic energy is decreasing. In here the potential energy is maximum. So this serves or this conserves the total energy. The speed is changing and use conservation energy at point A to C to find. Yes, yes, Maria, that is correct. Yes, that is what we are aiming to do. Yes. Yeah, so if you have to use this equation 6, right? So E is 2 mgr plus half m and Vc square we have just find out. So Vc square is mgr or gr, right? So that is gr. So 2 mgr and then half mgr, that would be 4 mgr plus mgr divided by 2. So that is 5 mgr by 2. So this is the total energy. We will use this total energy as Maria is saying. We will put this in here in equation 2nd, right? And we will directly get what is VA. So let's put it in here, right? So let's put it in here. So using equation 2, total energy is simply half mVA square. And this is 5 mgr by 2. And this is half mVA square. So m cancel, 2 cancel, and VA is root 5gr. Right. So this is the thing that we have to remember. So at A point, the velocity is root 5gr, and at C point, velocity is root gr. And let's find out the value at B. So where is B? Yeah. So we have to use equation 4. So we will use equation 4 and E mgr plus half mb square, right? So using equation 4, E is what was mgr plus half mvb square, right? So this is 5 mgr by 2 minus mgr, and that is half mvb square. So how much is this thing? 2. So 3 mgr by 2 half mvb square. 2 cancels, m cancels. So VB is root 3gr. So I have derived these things, but you guys have to remember. You have to make a short note, and you guys have to remember that at different places, right? At different places. So at this place, the velocity is simply root gr. At this place, velocity is simply root 3gr. And at this place, velocity is maximum. So this is root 5gr. Right? So if, and this is the minimum tension that we have considered. Right? This T3 can be anything. Right? But we have considered that this T3 is minimum. That is 0. Then we have got these results, right? So are these things clear to everyone? Is it clear? So this is vertical circle. Is it clear, everyone? Okay, so you
Yes, sir.
guys, yeah, so you guys have to, no need to note it down. But yeah, just to understand this thing, just note it down, right? So quickly note it down, and then we have to do so many questions. Collision, right? When we will talk about collision, I will just write the results, right? Because if I derive that thing also, so then we would be lagging behind with the syllabus, right? Because in the next class, I have to somehow solve, yeah, I have to somehow solve or start the AC, AC part I have to start. So quickly note this one down, guys, and yeah, we'll start doing some questions. So first I'll start the vertical circle question. So this question we'll do, and then we'll solve the work energy theorem question. Want, yeah, whenever you guys want me to scroll down the screen, please tell me. Okay, who's texting? Yeah, noted everyone. Is this, did you guys note down this part? Okay, so Maria has noted, so then quickly note down this thing. So in free body diagram, you have to just remember that we have to detach everything, right? We have to write every mass is in different components, right? So if we can part-wise just divide those things, then the answer would be simpler. Yes, done everyone. Whenever you guys have completed this thing, so please tell me. So you see that the velocity is decreasing, right? Velocity is decreasing, and to this is the minimum speed that we should provide that this completes one circle, right? If we provide more than this velocity, then it will surely complete a circle, right? So, but if we, this is the minimum speed with which we should provide this thing a speed that it completes one circle, right? So you saw the example when I was rotating. So in that example, I was not providing this critical speed, VA, root 5 GR, right? So if I would have provided this velocity, then it would have completed one rotation. So this is the minimum speed that you have to provide that it will complete one circle. And this speed is maximum, then this decrease at this point. So at this point, the speed is minimum. Okay, noted everyone. Yes, guys, noted. Yes, guys, noted. I guess you guys have noted, right? So you guys are not responding, so I will assume that you guys have noted it down. And yeah, if there's also this one thing that you have to remember, that if we cannot neglect the tensions, right? So if we write the tensions, what did we find out? If we write the tensions, so this is T1, and we found out that T1 is MVA square by R plus mg. So this was T1. What was T2? T2 was simply mvb square by R. What was T3? So T3 was mvc square by R minus mg, right? So if we cannot neglect this thing, so we can say that which tension is maximum, at which part the tension is maximum. So this is the maximum, VA is maximum, so T1 is maximum, right? VB is smaller than this thing, and this is VC, which is also smaller than this thing, and then we are also subtracting mg. So this part is minimum tension. Is it clear, guys? Okay, if it is clear, then let's yeah. So let's do one question, right? And then this would become more clear, right? So let me pick that question. So drop from an automobile pendulum has a speed, a constant power delivering, which okay. So this thing, let's do this. Okay, yes, what is happening? Okay, now what has happened to this thing? Okay, what is let me just cut this thing, and then let me just reopen this. Okay. And let me open my OneNote. Again, and then this will be, hopefully that works. Okay, is it working? Yeah, so it is working. Okay. So that a small bob tied at one end of a thin string of length 1 m is describing a vertical circle so that the maximum and minimum tension in the string. So they have given the maximum and minimum tension, right? The velocity of the bob at the highest position is how much? So now we cannot neglect the minimum tension, right? They have given the relation. And what is the relation that we already know? So we already know. We'll use the idea that we have done, right? So we will use what they have said that T max by T min, that is how much? 5 by 1. And we know that. What is this thing? T max is how much? T max is MVA square by R plus mg, right? So MVA square by R plus mg divided by what was the MVC square by R minus mg, right? So MVC square by R minus mg. We have to find out the VC, we have to find, right? Okay, so how can we find that out? And this thing, if we simplify this thing, if we take this thing in the other side, so mv square plus mgr divided by r divided by mvc square minus mg. And now we can also take out this m. So if we take out this m, so what would be there? VA square plus GR divided by VC square minus GR, and this is equal to 5 by 1, right? So what is the equation that we have? We have VA square plus GR, that is equal to 5 VC square minus GR. So what do we have? We have VA square minus 5GR. So this is the thing. Do we have any other thing that we can use? Any other relation that we can use? Can you guys tell me? What is the other relation that we can use in here? Ultimately, we have to find VC. So the velocity of the bob at the highest position. At highest position, your tension is minimum. How? Because in this equation, you have two unknowns, VA and VC. So I need one more equation which relates VA and VC. Can you guys tell me what can be that equation? What can be that equation which will relate Yes, guys, please tell me. Any guess? You guys can also guess, right? Any idea that is coming into your mind? So this thing we have already done, right? That is why I directly wrote these. But the other relation that we have also used can be the other relation that relates VA and VB together. You have 2 points, maximum, minimum. Yes. Anything that is coming into your mind, guys? Anything? Nothing. Okay. So you guys have this diagram, right? One thing is always there. Do you have this VA and you have this VC? You have 2 points. This is the reference. So whatever the energy at this point, that same energy would be at here. So energy conservation, right? Energy conservation. So total energy at A, that would be equal to total energy at C. So this is, at A you only have kinetic energy, half mVA square. At this point you have mg 2r plus you have half mvc square, right? So m and m you guys can cancel, and what we will have, so let's multiply all these equations with 2. So we have va square, that is this is 4 gr, and then we have, this is multiplied with 2, so this is vc square. So this is va square. This thing we can use, right? Right, everyone. So if we use this thing in here, so what we will have? So we have VA square, that is 4GR. Let's name it O1. So using in O1, right? And what plus GR, and we have 5C square minus 5GR. So all these GR in the left hand side, VC in the right hand side. So 4GR plus GR and then 5GR. So minus VC square. So 4VC square. So VC square is how much? That is root of GR by 2. This is 2, this is 5. So root 5GR by 2. Right. And we have G value, which is 10. R is 1 meter they have written. Right. R is 1. So, okay, but yeah. So this is, R is 1. So this is by 2. This is 5. And we have root. So this is 5 meter per second. So this would be VC. Clear, everyone? Is it clear? Yes, guys, is it clear? Good. So please note it down, everyone. Please note it down, and then we will do the next set of questions. So yeah, who's not here? Okay, so Iyad got disconnected. Yeah, Iyad got disconnected. Let me have some water. So today I'm totally exhausted. So yeah, I'll be back in a moment, right? Meanwhile, you guys please note it down. Yeah, if you guys have any doubt in this question, please tell me. And yeah, so whenever you guys have noted it down, please tell me. Oh, so two people got disconnected. You got Fadil has come and Shahid got disconnected. Yeah, so please quickly note this one down, and whenever you guys have noted it down, please tell me. Okay, I guess I have to take one class more for this work energy. This chapter, along with laws of motion, these two chapters are most crucial chapters, right? So if we have understood these things properly, then everything would be fine from the 11th part, right? Because because motion in 2D, motion in 1D, vectors, these are easier ones. Laws of motion, work, energy, power. These are tough ones, right? So, okay. So whenever you guys have noted it down, please tell me. I will do one more important question and then, yeah, then let me see which question I have to skip. But yeah, firstly, you guys tell me if you guys have noted this one down. So how much Pawan sir has completed? What is the chapter that sir is doing? Yes, guys. What is the chapter that he is doing currently? Yes, my silent pupils. Yes, guys. Are you guys exhausted also? I guess that, yeah, so you guys maybe are very tired. So, okay, someone also. Fadil also got disconnected. So many people are getting disconnected, right? Yes, noted everyone. Noted. Quickly tell me. Okay, so yeah, so then let us do a simple one, right? But before I do that, let me just bring that very important question. So I will bring that question in here and then we will do the other ones, right? So all these things are very simple ones, right? An automobile accelerates starting from origin and while the engine supply constant power T, the position is given as function of time by. So this is a very simple question, right? We can do this one, but yeah, so this one we can try. So power is constant, right? And what is the relation between power and work or force, right? We can relate force with power. So that thing we have also understood. And we have to apply those things And yeah, we have to get. So this is the thing, right? Okay, so I will just give you guys some hint and you guys try this one. So you guys have to try this one. Right, so power is constant. Right, P is constant, and you have to relate, power is related with force, right? Force into velocity. So this is power, right? And you know, so this is constant, and you know that how velocity is related with, right, everything, and how acceleration is related with everything, right? So you guys have to find out what is the position. So x you have to find out, right? So yeah, use this relation and tell me that what would be the a for x. So you just have this, remember that this is a constant. F is ma, and then you have this v, right? So your av, this is simply, right, this is simply p by m. And a is how much? A is dv by dt. So this is p by m. So v dv is p by m and dt, right? So this thing you have to find out. You can calculate v, and using that v you can calculate also the x, right? So please do that and tell me what is the answer you guys are getting. Remember, it is starting from rest. So initially it is 0. Yes, guys, what is the answer you guys are getting? So whatever v you guys will get, whatever v you guys will get, you have to just put that as dx by dt. And then you have to integrate it again so that you get, right. So you have to integrate this thing so that you will get x. So that is the idea of this question. First, you have to find out v, and then in the second step, you have to find out first find out v from here, and then find out the x. Please tell me what is the answer you guys are getting. Yes, solve this thing and tell me what is the answer you guys are getting. Yes, no one got the answer. What you guys are solving? So first we have to solve this thing, right? If we integrate in both the sides, p is constant. So what would be this thing? This is simply v square by 2 from 0 to v, and this is p by m, that is constant. And this would be simply t from t to 0. So this is simply v squared by 2. This is p by or pt by m. So your v is simply root of 2pt by m. That is your v. And then you have to integrate this thing again. So what would be this thing? So this is v is root of 2p by m, that is constant, and root t dt, right? So this is from 0 to, let's say, t. So this is 2p by m power half, and then you have this thing, t power half. So what would be this thing? This is 2p by m power half, and then t half plus 1 and half plus 1. So how much is this thing? So you have 2p by m half t3 by 2, and then this is 3 by 2. So how do you write this thing in root? So this thing is 2p by m. This 2 will go in here, so 2, and I can write this thing as root of 9 by 4, right? Or I can write this as 9 by 4 power half. So this thing I can now take into in here. So what would be this? This is 8 p by 9m power half, and then t3 by 2. So that would be the x. Is it clear? So we have to do two integration here, everyone. Yes, is it clear? So what is the answer? 8p by 9m t3 by 2. So this one is the answer. Okay, so please note this thing down, and then, yeah, and then we'll stop, right? So, okay, we'll stop, and then we'll do this. We'll continue this in the next class. So whenever you guys have noted this thing down, please tell. Or we can do one more question, right? So yeah, we can try one more question. We can do that question. That is very important. So whenever you guys have noted, please tell me, right? So this is the first part, and then this is the second part. So first we solve this, and then we solve this. Oh, so somebody got disconnected. So okay, Madiha part. So yeah, we'll stop there because okay, noted everyone.
Yes, sir.
Yeah. So remember, we didn't use the idea of equation of motion. We didn't write v equals to u plus at or the other thing, right? Because acceleration was not uniform, right? So we use the idea of differentiation and integration. So that thing you have to be always careful with. When we have to use equation of motion, when we have to use the calculus part. So this thing you guys have to be very careful, right? So we'll stop here and we will continue from here in the next class, right? So we have a couple of